Got it. Okay, that's cool. Let's see. I gotta log in there too. Let me log in first. Give me just a moment. We can close that out. Continue my session. Is it gonna let me? Of course not. All right. Log in. Come on. You okay? We are right here. 2 p.m. And one more click. Come on, let's go. Right here. Quadratic functions. Cool. We'll let that chill right there. All right, so let me show my screen. Start the broadcast. And we'll start off here. All right, so greetings, scholars. Welcome. Let me see. As far as announcements, I'm still working on midterm grades, so you just have to bear with me. I have one class that's on the Porter system, and so this is like my first time working with them. So it's like their grade book was like really wasting a lot of my time, but I got to the bottom of it. So that's what's been causing the delay, just trying to figure out, there's a lot of things that were out of my control. So anywho, but your midterm grades will be updated probably within the next day, if not the next day, within about the end of the week. And your midterm grade, all it is, it's just going to be based on everything from the beginning through exam 2. There's no midterm exam. It's really just a snapshot of where you are at that moment in time. All right. So it's going to be based on exam 1 and 2. What I'm going to do is take the average of those exams and scale it so that it's like 80% of your overall grade. And then I think any homework and quizzes, I'm going to take their average, and those are going to be the remaining 20. So the homework is 10 and the quizzes are 10. But again, it has no bearing on your final grade. Again, it's just a snapshot. If your grade is lower than what you would like, it's probably a good idea to go back and submit, like either improve your scores or submit any and all missing assignments. If you are going back and submitting old assignments to boost your score, I would encourage you to prioritize your exams where that's where you're going to get the most bang for your buck. You're going to get the most movement in your grade the higher your exam scores are. Once your exam scores are where you'd like them to be, if you feel up to the task or you just need more practice, then I would go and do the quizzes next. And then the thing I would say for last are any old homework assignments, because the homework is going to be a lot of work for little points. It'll be good practice and you'll be learning, but if you're trying to be efficient and a little bit savvy, order of priority is the exams and then the quizzes and then last are the homeworks. As usual, if you have questions, feel free to unmute yourself to get my attention or type it in the chat and we can talk about it. We're pretty much at the 15-minute mark. I'll still check attendance again. I'll check it periodically for anybody that's coming late. If you're ever late to my course, like if you just hang out in the waiting room, usually I see it. Like I know in my earlier class today, I had somebody that waited all the way until the 45. And so I was like, okay, like the very last second of class. But I was like, okay, well, since I saw him, I went on to give him credit. I really don't want attendance to be an issue, especially for somebody that's making some effort to be here. But, you just got to be careful because sometimes I don't see those students, right? So like after that 15-minute mark, you're kind of at my mercy. Okay, so Monday we were working on section 2.1 quadratic functions. So today we're going to go through as many of the corresponding homework from section 2.1 together as we can. Let me see. Hey, Google, give me a random number between 1 and 19.
1.
Okay, I guess that's inclusive. That's fine. All right, so identify the graph of the following quadratic function. All right, so we do have a U-shaped curve. We multiplied the outside by a number between 0 and 1, so that's going to cause a vertical compression or a vertical shrink, so it should be short and wide. And then we also multiplied the outside of our base function by a negative. So that's like our y values are going from positive to negative, so it should be upside down. So it's a wide U-shaped curve that's upside down, and we didn't move it up or down at all. So the vertex should be at the origin. So I'm gonna go with B. Let's go with B and submit. Since it's officially the 15-minute mark, let me just check you guys again in Zoom. See some activity in the chat. Yeah, so if you're just getting access, the best thing is just to go ahead and submit your assignments. Yeah, the simple thing is just submit the assignments. That's the simple thing. And I mean, honestly, even if you do get the late penalty hit, you actually be fine. Like, you got to work a little bit harder, but again, we get unlimited attempts, so you can still earn a 90% on things that are late. All right, that's because I'm just trying to think. Give me a moment. Yeah, I didn't. It's kind of a pain. Like, I didn't want to have to like do a whole bunch. I tried to automate it as best I could. Baseball. Okay, so if there's a question with the homework, especially if it's from the homework, find it on your end and click on the Ask My Instructor. Once you've used the Ask My Instructor, you sent the email. Basically, what it does is it takes a screenshot of your very question and it sends it to me. Once you sent that Ask My Instructor, let me know and I'll pull it up. If it's from a quiz or an exam, and then the process is just screenshot it and email me, let me know and I'll pull it up. Okay. Or if it's, if you know which question in the homework it is, we can just go straight there as well. But yeah, for right now, for the person that's getting late access, the simple thing is just go ahead and submit your assignments. There is a 10% late penalty. Yeah, that's a simple thing for right now. Just go ahead and do that. All right, let's get started. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 10.
All right, let's try 10. Graph the given function by writing it in a standard form and then using the transformations to find the vertex, right? So to write this in standard form, we usually use completing the square. I think I'm going to take some notes here. Let me think. The completing the square step, the first thing is that the leading coefficient needs to be a 1, and it is a 1, so we're clear there. And then we add 0 in the form of b over 2 squared, right? Our b in this case is 4. So if we say 4 divided by 2, that's going to be 2, and then 2 squared is 4. So we're going to add 0 in the form of plus 4 minus 4. So if we add plus 4 minus 4, those first 3 terms we can factor. Type an equation. Okay, let's get rid of this. If I need to write out what I'm saying, like, so you can see it, just let me know and I will. Okay. Let's go like this. Oh no. Y equals. Is your battery low? Oh, I know what's going on. This thing, maybe. Y equals. Okay, there we go. Let me see. X squared plus 4x plus 4 factors into x plus 2 squared. Let me see. We had plus 4 minus 4, so then there's a minus 4 out here. So that in standard form should be this guy. And again, to write this in standard form, we use a factoring technique called completing the square. So when I say that phrase of completing the square, if you don't resonate with it, or if it's not if you're not 100% clear, I would encourage you to do a YouTube search and watch a few different presentations on multiple content creators using the technique completing the square. I've done it in class, and it just helps to see it done a couple of different times, and then hopefully it sinks in. But it's a factoring technique. Okay, so let's go with this. Let's hit enter. Okay. So then once we get the quadratic in standard form, we can quickly identify our h and k, which is going to be the vertex of our parabola. So, if we're using transformations, okay. So if we're going to describe this in transformations, we're starting with a U-shaped curve. So that's the x squared. And then we work our way from the inside to the out. So the innermost manipulation, we added 2 on the inside. So that moves it to the left 2 units. So you take the U-shaped curve and shift it 2 units to the left and then 4 units down. Oh, you're doing that thing again. Come on. 4 units down. Okay, let's go with that. So then if we click, it's just a U-shaped curve. I think we said we went left 2 and down 4. So I'm just going to click randomly. I just clicked it randomly on the thing. Then we said we went left by 2. So I'm going to slide this to -2. And we went down by 4. Okay, those are the only manipulations that we did. Let me hit save. That looks good. And we're going to go with that. Use the graph of the tool. What's the vertex, right? So in that standard form, remember the standard form is x minus h squared plus k. So because we have x plus 2, we need to rewrite it as x minus a -2. So then once we rewrite it as x minus, now we see that our h is -2 and our k is -4. So then we're going to put -2, -4. -2, -4. Okay. The axis of symmetry. So once we have the vertex, the axis of symmetry is the x coordinate of the vertex. So that's going to be x equals -2. Okay. X-intercepts. To find the x-intercepts, we set y to 0. I feel like with the quadratic, when it's in standard form, that's a relatively easy place to start to find the x-intercept. If we set y equal to 0 from the standard form, we add 4 on both sides. We take the square root on both sides. That's going to give us plus or minus 2. And then we subtract 2. So it's going to be -2 minus 2 and -2 plus 2, right? So that's going to be -4 and 0. So, and you can see it in the graph, right? -4 and 0. So the x-intercepts are -4 and 0. And again, if I need to write something out, just let me know. I know I'm kind of like, it's kind of hard to like visualize it audibly, but I feel like these are kind of okay, you know. The y-intercept, now oftentimes I feel like the y-intercept is easier to find than x-intercept. The y-intercept, to find it, we set x equal to 0. So then you see in the original, if we set x equal to 0, then y is going to be 0 in this case. All right, but oftentimes the y-intercept is easier to find than the x-intercept. Not all the time, but most of the time. That's been my experience. Okay, let me check the chat again because I know there was a request. Let me see if I don't know if you sent the email or not. Yeah, I just don't know which question. If you can tell me which question that is, I can pull it up. Let me check my email to see. It's been sent, cancel. Interesting. Okay, so I don't see anything. All right. Let's see. Hey, Google, give me a random number between 1 and 19.
Here's a random number.
13.
12.
Oh, I was close. I was thinking 13. I generally choose 13. For this equation, determine whether the graph of the quadratic function opens up or down, find the vertex, find the axis of symmetry, find the x and y intercepts, and then sketch the graph. Okay. So for part A, does the parabola open up or down? So the direction in which the parabola opens is based on the leading coefficient. The leading coefficient in this case is a +1. Because the leading coefficient is positive, that means our parabola opens upward. Okay. So then the vertex. So we have a vertex formula that'll take us straight to the vertex, right? We could do completing the square, put it in standard form, and then it'll reveal the vertex to us. or we can use the vertex formula, right? So the vertex formula goes as follows. Our h, which is the x coordinate of our vertex, is going to be negative b over 2a, right? So I'm just taking my notes here. So that's pretty much the vertex formula, that formula there. And basically, go ahead. Is there a question? You sent the email? Let me see. I'm looking now. It's question 18. Okay. We'll do question 8. All right, I'm mute. I don't know. But we'll do 18 next. Okay, so this is the vertex formula. And again, this takes us directly to the x coordinate of the vertex. So let's keep going. So then our b in this case is going to be -4. So then -4 becomes a +4 divided by 2 times a, which is just 2. So then 4 divided by 2, ultimately. So the x coordinate of our vertex is 2. Okay. So we have the x coordinate, and then once we have the x coordinate, we just pass it through the function to get the y coordinate. 2 squared is 4, minus 8 is -4, minus 12 is -16. So when x is 2, the corresponding y looks like it's -16. So then the coordinates of our vertex should be 2, -16. Okay, so I think there was a request for question 18. So I'm just going to go straight to question 18. What? Did we not finish this one? Oh, we haven't finished. Okay. The axis of symmetry. So once we have the vertex, the axis of symmetry is going to be the x coordinate of the vertex. So that's going to be x equals 2. Okay. The x-intercepts. Okay, can we factor this guy? Let me see. So, we want to set the equation equal to 0. And we want to see, can we factor it into some form like this, where we have an x and an x. Because the second sign is negative, I know my signs alternate, so one is positive and one is negative. And because the first sign is negative, I know the larger number is negative. So we're looking for two numbers that multiply to give us 12 and add to give us 4. It's not 4 and 3, 6 and 2, right? And we said the larger is negative, so 6 and 2, right? 2 times -6 is -12. 2 plus -6 is -4. So then if we set each of these to 0 and solve x-intercepts, we're going to get what? -2 and +6. -2 and +6. And let me get rid of my notes. I'm just taking my notes here because it's a fine line between being lazy and being efficient, right? Like, on the surface, it looks like I'm being lazy, but to me, I'm being efficient. I'm just trying to streamline. But if I need to write stuff out, just request it. Okay. So these are the x-intercepts I got. I'm going to go with these. Okay. And then the y-intercept, right? We set x equal to 0. You can do that in 2 seconds, and then we see the result. It should be -12. So if you let x be 0, only thing that's remaining is that constant term because there's no x there. Let's see. The coordinates of our vertex. We had 2, -16. Okay. 2, -16. Click. Just want to at least be able to see the function. We know we're working with a parabola. I'm just going to click in 3 random places. Okay, I clicked in 2. Now our vertex was 2, -16. So I'm going to drag this vertex to the proper location. Okay. There's my 2, -16. And then with this tool, we really only need one additional point other than the vertex, right? So I'm gonna find the corresponding y when my x is, I'm gonna let x be 1. That seems like a fairly simple number to choose. Or we can, honestly, even easier, we can just let x be 0. When x is 0, the corresponding y is -12. So let's just do 0, -12 and call it a day. Boom, just like that. And that's more than enough. -2 and 6. It looks a little off. Let me hit save. Yeah, we're good. -2 and 6. Yeah, everything else is there. Okay, I'm gonna go with this. God is good. Okay, so there was a request for question 18. Sometimes I feel like a rapper because I talk so fast, and sometimes it has like weird rhythm and syncopation. Peter Pepper picked a pack of peppers. How many pack of peppers? I could never get that. Or either try holding your tongue and saying red leather, yellow leather real fast. This one is fun, right? I think I'm gonna take some notes here. Okay, let's and let me zoom in just a little bit to get a better image. Let's do one more. Yep. Okay. So I'm gonna get this and take some notes. I'm kind of excited today. I don't have to meet with my evening classes because like we're in a down week. Like they're on a quarter system, so they finished last week. So that's like I said, that's what's been kind of like copy and delete, causing part of the delay as far as midterm grades. So, but I don't meet with them then. Next week. I get a whole other set of students. Okay. So we have all the relevant information for this question here. Okay. All right. So this is question 18. It comes from section 2-1, question 57 from the back of that section. It says, fencing with a length of 480 meters surrounds two identical playing fields with a common side. The fields can be side by side and separated by a fence as shown in the figure. Find the dimensions and maximize the area of each field. Okay. So it looks like we're working with perimeter and area, right? Let's just realize I don't have that color. Can I add some more colors? I need another palette. We'll just do this one for the sake of simplicity. I don't want to get rid of that. I use all of these guys. Okay, it's okay. I'm going to just give my own image real quick. Let me try that again. Okay. I want to bisect this. I guess that's the middle there. Okay. So it says fencing with a length of 480 meters, right? Two identical fields. Find the dimensions and maximum area of each field, right? Okay. Let's see. So I'm gonna let this be my X from here to here. I'm gonna let this be my Y from here to here. Okay. So then one equation that we can write is like the perimeter, the distance, the sum of all the sides, right? So we can say that the perimeter, we have what? 2 X's on bottom, 2 X's on top, so a total of 4 X's. So we can say 4X plus, and we got a total of 3 Y's. And then we have a total of 480 meters of fencing available. Okay. So that's one equation using X and Y. And then we can write another equation for the area of each field is just going to be X times Y. And again, we want to maximize the area, right? We want to maximize this guy. Okay. So we have 2 equations, we have 2 unknowns, we essentially have enough to solve. Let's solve for, I want to solve for Y from the first equation, so that way my final equation is in terms of X. If I solve for Y in the first equation, let me see. We're going to have 3Y equals 480 minus 4X, okay? If I divide both sides by 3, Y equals, let me see, that's 1, 18 is a 6, and then 0. Okay, minus 4/3 X, okay? So when we solve for Y from the first equation, we get this. Then we want to take this and plug it into the second equation. Again, our goal is to maximize the area that's going to be x times this y. 160 minus 4/3 x. Okay. Okay. So then let's distribute this x and kind of rearrange it and rewrite it and see what it's looking like. So then the first, and I'm going to put it in this descending power order. So we're going to have a negative 4/3 x squared plus 160 times x, right? So now if we were to look at this graph, notice that this is going to be, the shape of this is going to be a parabola, right? It's the highest power is a 2. So that means we're going to have a U-shaped curve. The leading coefficient is negative. That means our U-shaped curve opens down. Because the U-shaped curve opens downward, right? That means we're going to have a maximum value. That means we can maximize it. So because we're dealing with a parabola or a quadratic, the max is going to occur at the vertex, right? At the vertex. So if we just find the vertex, I think we'll have everything that we need. So I'm going to use the vertex formula, right? So the vertex formula, the x coordinate of a vertex, which is h, that's going to be negative b over 2a, okay? So that's going to be, our b in this case is going to be 160 over 2 times our a is, thanks, thank you, thanks. She'd be quiet all day, and then I started teaching and she wanted to warm up the vocal cords. Thank you. Get down. Thank you. All right, right? So if we keep going, double negative becomes positive. Whenever we divide by a fraction, it's the same as multiplying by the reciprocal, so we can flip and multiply. Really what this is 160 times 3 over 2 times 4. Let's see. The 2 can turn the 160 into 80. The 4 could turn the 80 into 20, and it looks like we finished with 60. All right. So the x coordinate of a vertex occurs when x is 60. So then our k, which is the corresponding y, is going to be f of h. So in our case, that's going to be f of 60. We plug 60 into our formula to get our y. Okay, let me see. Hey, Google, what's a negative 4/3 times 60 times 60 plus 160 times 60?
Minus 4 divided by 3 times 60 times 60 plus 160 times 60 is 4,800.
4,800. Okay. So then the coordinates of a vertex should occur at 60, 4,800. Okay, and let's interpret, what does this mean? So our maximum area is going to be 4,800 square meters, and that occurs when x, let me see. So we're claiming that x, the area of this field is going to be maximized when x is 60 meters. But if x is 60, that means our y, let me see, 6 divided by 3 is what, 2? So that's a negative 80. It looks like it's an 80. Is 80 meters, right? So when x is 60 meters, y should be 80 meters. The area of this field is 80 meters. The other area should also be 80 meters. The other area should also be 4,800. And then we just need to confirm that these two work as far as our perimeter goes, right? So basically it's 60 times 4 plus 3 times 80, and it should be 480. Let me see, I'm just gonna use the calculator. Hey, Google, can't get talk. Cancel. Hey, Google, what's 4 times 60 plus 3 times 80?
4 times 60 plus 3 times 80 is 480.
All right, so these dimensions satisfy both equations. It maximizes the area because it occurs as the vertex, right? And it matches our perimeter. So these should be the dimensions for this one. So we got 60 by 80. The larger dimension of, let me see, the larger dimension of each field was 80 meters. And the smaller dimension was 60 meters. The maximum area of each field is 4,800 square meters. All right, that was a fun question. I like stuff like that. It wasn't always that easy, but you know, only reason I know it is because I do it like every day. Like so I see it. But you have to start at some point. You'll see it, and with exposure and repetition. Not that it means anything. It's just that's the only reason I know it is because I've done it so many times. And like I kind of know like what I'm looking for, what I'm setting up, and stuff like that. You could do it too, but again, it doesn't really mean anything unless it's time to go. Unless you figure out. I feel like this stuff has a lot of power. These topics that we're talking about, but it's only powerful if you use it, right? And like some realms where this stuff is applicable is obviously like construction, but it also plays into like systems. Like if you were a city planner, if you were like trying to make the highways, like if you were trying to make the highways like the commute for a commuter, obviously that's redundant. But if you were trying to minimize the commute for the citizens, this is the kind of stuff that you would be using. I mean, obviously we're going to use like data and like geometry. I like for instance. On the south side of town, when you would come, north on 285 on the west side, approaching Camp Creek, before they did the reconstruction, that line to exit off of 285 on the Camp Creek used to be like 1 to 2 miles long. I mean, it was ridiculously long, right? You would be better off just going up to the next exit, and taking some street ways to get to your destination instead of trying to go through that intersection. But I really like I really, really like the renovation that they've done to the intersection. They introduced this technique called the diamond intersection, where the traditional exit, you're exiting, you got to sit at a light, and then if you're going left, then you're going to have to sit at another light while you wait on the bridge. That happens often, right? But with the diamond intersection, it prioritizes people getting on and off the highway. So like, say you're on the street and you're approaching, like you say you want to go north, you can just turn right. That's like a normal right. Like if you're heading west on Camp Creek and you want to go north on 285, so you can actually just make that right and bypass the light. And then if you're going south on 285, you have to wait at most one light. In the past, it would be 2 lights, but with the diamond, once you get through that first light, it shifts the traffic to the left side of the road. So that way, if you need to make that left onto the highway, you can do it without even having to wait. So now you've turned this intersection that had like poor efficiency where many cars often had to wait at 2 lights. Now all the cars have to wait at most at 1 light. If you're going straight, like passing on the overpass, your chances of, let me think about it. Yeah, your chances of, I think you really only have to wait at 1 light still. Your chances of getting caught at 2 lights there are like rare because the people getting on and off the highway, they don't have to wait. So there's less people that's going to be caught at that light. It's really trippy, and it's like when I first came across it, I was like, what is this? And then I had to think about it. And that's the conclusion I arose to in my mind. I was like, oh, that makes a lot of sense. Like, so the diamond intersections along with the roundabouts, I like those too because as long as the coast is clear, you don't have to wait. Like I'd be fuming. I'd be sitting at lights and there's nobody else at the light, but because if I run a red light, either I get caught on a speed camera or if a cop sees me, they'll harass me. All right. But I'm like, there's nobody here. Just let me go. Now, if I was in like India or something like that, they don't care. It's chaos. Like, you got to just like go where you can get in. But it's not that simple here. I had a cop once pull me over for making a right at a red light. He was like, that's a no turn on red. I was like, are you serious? I was like, come on. So anyway, I mean, he ain't had nothing better to do. But it's okay. I mean, it's in the past. So anyway, that actually officially brings us to the end of today. Let me check on you guys in Zoom. Are there any burning questions before we go our separate ways? Any burning questions? Going once, going twice. Okay. All right, so we got to the bottom of that one. If there aren't any announcements, just keep submitting your assignments via My Open Math, and we'll reconnect on Monday at the same time, same place. All right. And again, if there aren't any burning questions, we're going to end this session here. And from one beautiful mind to another, have a great weekend, guys. I'll see you next time, same place. Take care. Peace.